I thought I would give you a video explanation of this assignment in addition to the directions that I have on the front of the assignment. So on this first page of the atomic structure worksheet, you need to fill in each part of this table. I have different things in for you to try to use so you can look around the periodic table to determine what each thing is. So if you notice on the first line, we have just the symbol IN. So if I go throughout the periodic table, I find that it is indium. So what you're going to do is inside this box, you're going to type indium. Then you're going to look at the atomic mass, and I see that the atomic mass is 114.5, and my periodic table at home has a bunch of small numbers after it, but we're going to round that to 115, okay? For this assignment, please use whole numbers. It'll make it easier for the rest of this data table. Now, if I look again, I see that indium's atomic number is 49, so I'm going to type that in. I'm going to skip over the neutrons for a second. I want to fill in the protons and electrons first. If you recall from your readings, you know that the atomic number is based on the number of protons, so I know I'm going to fill in that with the same number as the atomic number. And because I have 49 positive charges, to make this a neutral atom, that means I have to have 49 negative charges. So these three columns will be the same. Cuts the work in half. Now, to figure out the number of neutrons, if you recall, the atomic mass is based on the number of protons and the number of neutrons. So what I want to do is take my atomic mass, subtract my atomic number, and here I get the number of neutrons. So if I do my math correctly in my head, I believe that is 66. Nope, I don't have a calculator in front of me. You guys can double check and you can let me know if I'm wrong. Do it nicely, please. Okay, now you notice this second line, all I have is the number 5. That's the difference between my atomic mass and my atomic number. So somewhere on the periodic table, there's going to be an element whose neutron's number is 5. Well, I know it's not going to be hydrogen. It only has an atomic number of 1, so it can't do much there. Helium has the atomic number of 2, the atomic mass of 4. 4 minus 2 is 2, still can't be it. Lithium, ooh, that's got an atomic number of 3, and the atomic mass rounds up to 7. 7 minus 3 is 4. We're getting closer. Beryllium has an atomic mass of 9 and an atomic number of 4. 9 minus 4 is 5. That tells me this is beryllium. So I type it in. I'm going to put in my symbol, Be. I said the atomic mass was 9. The atomic number is 4. That's the same as my number of protons and the same as my electrons. All right, you're going to fill in the rest. Now, when you get down here towards the bottom, we have one more of those guess and check ones. The difference between the mass and number is 125. My clue to you is this is the lower right-hand corner of the main part of the periodic table. There are more than one options. You only need to pick one. Go ahead and do it. Now, on this second page, you're going to fill in each of these spots and use these keys to help you out. So hydrogen, and if you need to, put the symbols next to them. So hydrogen, the symbol is H. I'm just going to put a capital H to remind me, and then I can fill in the information. It has 1 electron, 1 proton. The atomic mass is 1. Minus 1 means it's 0. Okay, and if you need to make everything fit, take away a little bit of the line that I gave you, and everything should be good to go. When you fill in this whole second page, you are then going to use that information to do the orbital diagrams. Now, unfortunately, because we're doing everything on a computer, and I don't have that great of computer skills, we're not going to be able to actually draw what an orbital diagram looks like. So what I want you to do is, and this is where your page will get bigger, under hydrogen, oh, it's not going to let me do what I want. I'll do it this way over here. Come on. All right. Sorry, folks, technical difficulties. All right, under hydrogen, first thing I want you to do is put the word nucleus. Inside the nucleus, you're going to have your protons which we know is 1. You're going to have your neutrons. If I can type, we know that's 0. Put a dash line here because then it's easier to tell what the heck we're talking about. Then I want to know how many electrons are in each energy level. So first energy level, there is only one electron. But if you look on that white periodic table that says orbital periodic table in the white resource folder, inside each box there's a column of numbers for the elements. And that tells you how many electrons are on each energy level. The first number will be the first energy level. The last number is the last energy level. So if I look at sodium, I'm going to have 3 energy levels. Okay, so sodium has the symbol Na. Inside the nucleus, the protons, same as the atomic number, is going to be 11. The neutrons, atomic mass, minus the atomic number, we're going to take 23 minus 11, that gives me 12. All right, the first energy level, there's going to be 2. That's the maximum you can have in the first energy level. Second energy level, there's going to be 8. That's the maximum number you can have in the second energy level. Third energy level, there's going to be 1. If I add them up, 2 plus 8 plus 1 equals 11, and that's the same amount of electrons. If you notice, these 12 elements are the same elements in the same order as page number 2. So you will have your number of electrons, your number of protons, and your number of neutrons to use here. The only thing I want you to do is use that periodic table with the orbital diagram and figure out how many electrons are on each energy level. All right, when you're done with the assignment, submit it through Schoology. Have a great day.